Hello everyone. Today we are going to explore a very powerful and fundamental concept. This is dot product, right? Especially from the lens of analytical geometry, right? Okay. We'll start with the basic understanding of what dot product is and how analytical geometry helps us understanding and calculate it easily. And finally, how this concept plays a big role in data science, machine learning, artificial intelligence, etc. Right. So, before that, before we get into the definition of dot product, what actually it is, you should understand what analytical geometry is. I'll write it here. What is analytical, or you can say as coordinate geometry. Geometry is. So this was designed by René Descartes, for your knowledge, where he made a difference between classical geometry, which focuses on abstract shapes and figures. It did not involve any algebraic equations nor directions. Okay, so analytical geometry, like also known as the coordinate geometry, is the bridge between the algebra and the geometry. It allows us to study the geometric shapes like circles, triangles, lines using numbers, coordinates and equation or algebra, right? But unlike this classical geometry, which just focused on the shapes, okay, but nothing like it did not any involve any algebra, or it did not any involve any coordinates. It was not represented graphically, right? So if classical geometry is drawing a triangle, let's imagine classical geometry is just this triangle. You have just this information. Analytical geometry is plotting it on x-axis and y-axis and measuring it precisely. Okay. Now let's get into this definition, the core of this video, which is the dot product. So let me select another color for this. I'll select blue here. Okay, fine. So dot products is also called as a scalar product. Scalar in the sense, it has, when you multiply it, you end up with a single value, right? There are two ways to define it. One is algebraic form using components. The other is geometric form using magnitude and angle. Two ways of representing it. So one is algebraic and other is geometric ways of representing this dot matrix. Okay, it's just a different ways, that's it, but both are same. So for example, let's explain this algebraic form. I have a vector which is a, the coordinates are 2, 3, and then I have b which is 4, 1. So the dot product is going to be, you're basically multiplying 2 into 4, which gives you 2 dot product of 4. Then you're plusing it, then taking the second component and of a and multiplying with the second component of b, is giving you 3 into 1, which is resulting in 8 plus 3, that is equal to 11. Okay, fine. So what is the geometric view? So geometric view is the same as a dot product. We can also compute using the angles between the vectors. Let me change the color here. Okay, see, listen, I have a vector a and vector b. Okay, so the dot product gives you, what it gives is, you're multiplying the magnitude of a and the magnitude of b with the angle between them. So geometrically we can write it as a dot product of b gives you this one, and cos theta, right? Again, so A is going to be the length of the A, which is magnitude, and this is the length of the B, and theta is the angle between those vectors, right? So for the above, let's take this example here. For this, let's compute in the geometric form. Okay, so what I am getting is I am applying the magnitude formula. So basically it is 2 square plus 3 square. That's what the coordinates we have, right? It's 2 and 3. So we are squaring it and finding the square root, which results in root 13. Again we are finding for B. So let me check the coordinates. It's 4, 1. So what I'm doing is I'm squaring it and finding the root, which is equal to root 17, right? Okay, so then what I'm doing is I am multiplying. That's a formula, right? 17. So I'm just making numbers, the theta to be 60 degree, so which will result into 21. So cos 60 is 0.5, is approximately equal to 7.43. So when we did the algebraic calculations, we resulted in 7 here, right? So here you get it as 7.43, which is not same because we just made numbers here, but actually this geometric wise or whether algebraic wise, both give you the same result. Okay, fine. Okay guys, so we know what is dot products. So let's see some use cases where this dot products is applied in artificial intelligence or data science. Okay, the first use case is cosine similarity. So using this cosine similarity or the dot product, what you can do is you can find the similarity between the documents and images, etc., right? So this use case comprises of the expressions of both the expression we saw, algebraic and geometric view. Again, secondly, the use case in recommendation system. So basically it is used to find the product similarity, user similarity, and user to item similarity, etc. Thirdly, it is used in neural networks. So dot products is the core of matrix multiplication in every layer of the deep learning, right? And the fourth one is in PCA. Like it's using the dot product, you project the data onto the components, and it's finally used in reducing the dimension. And also you can, and the fifth use case, you can tell it for NLP. You basically see how both the vectors are similar, how much are they similar, in what way, how much are the angles between them. So all these are basically done using the dot products. So that's it for the video. This is Lakshmi from the Skyverse Infinity Academy.